Ever wondered what would happen if our sun, the very source of life on Earth, suddenly turned into a black hole? The idea sounds like something straight out of a blockbuster sci-fi movie, doesn't it? What would happen to our planet? Would we be instantly sucked in and crushed? Or would something even stranger occur? Get ready, because today we're diving deep into one of the most mind-bending what-if scenarios imaginable. Make sure you hit that subscribe button, like the video, and ring that notification bell so you don't miss out on more cosmic adventures like this one. First, let's get one thing straight. Our sun can never become a black hole. It's simply not massive enough. To form a black hole, a star needs to have a core mass, at least 2 to 3 times that of our sun after it has exhausted its nuclear fuel. When a truly massive star dies, its core collapses under its own immense gravity, squeezing all that matter into an infinitesimally small point called a singularity. Our sun, being a relatively average-sized star, is destined for a much quieter end. In about 5 billion years, it will swell up into a red giant, shed its outer layers, and then settle down as a white dwarf, a dense Earth-sized stellar remnant. So, rest easy, the sun won't be giving us a black hole surprise party. But this is a what-if video, and that's where the fun begins. So, let's bend the laws of physics and imagine that, right this very second, poof! The sun is replaced by a black hole with the exact same mass. What's the first thing we'd notice? You might be thinking of a giant cosmic vacuum cleaner switching on, right? Well, you'd be wrong. Surprisingly, for the planets in our solar system, not much would change orbitally. Earth, Mars, Jupiter, and all the others would continue to orbit this new black hole, just as they orbit the sun right now. Why? Because the black hole has the same mass as the sun. Gravity depends on 2 things, mass and distance. Since the mass of the central object hasn't changed, and our distance from it hasn't changed, the gravitational pull we feel would be exactly the same. We wouldn't suddenly get yanked out of our orbit and spiral into oblivion. We'd just keep on circling this tiny point of infinite density, business as usual. A black hole with the mass of our sun would be incredibly small. Its event horizon, the point of no return, would only have a radius of about 3 kilometers, or just under 2 miles. That's tiny. The sun's current radius is almost 700,000 kilometers. So, unless you flew a spaceship right up to this new tiny black hole, you'd be perfectly safe from its gravitational clutches. From 150 million kilometers away, where Earth is, its gravitational effect is identical to the sun's. So if we wouldn't be sucked in, what would be the problem? The first and most catastrophic change would be the sudden and complete absence of light and heat. The moment the sun becomes a black hole, the light it was emitting would cease. But we wouldn't notice it immediately. Light travels at a finite speed, and it takes about 8 minutes and 20 seconds for sunlight to reach Earth. So, for those few precious minutes, we'd be blissfully unaware. The sky would look normal, the day would be bright, but then it would happen. Suddenly, without any warning, the world would be plunged into absolute, permanent darkness. Imagine the darkest night you've ever experienced, and then multiply that by 1,000. It would be a darkness so profound that you couldn't see your hand in front of your face. The moon would vanish, as it only shines by reflecting sunlight. The stars would blaze in the sky with an unbelievable clarity, a permanent, crystal-clear night sky, but that would be our only natural light source. The darkness would be accompanied by a terrifying drop in temperature. Without the sun's constant stream of energy, the Earth's surface would start to cool down rapidly. It would be like the entire planet having its power cord unplugged. Within a few days, the average global temperature would plummet below freezing. Within a week, it would drop to around -17 degrees Celsius or 0 degrees Fahrenheit. Within a year, we'd be looking at surface temperatures of around -73 Celsius or -100 Fahrenheit. Life on the surface would be doomed. Photosynthesis, the foundation of most life on Earth, would stop instantly. Plants would wither and die within weeks. Herbivores that eat those plants would starve, followed quickly by the carnivores that prey on them. The entire surface food chain would collapse in a matter of months. Humanity's survival would depend entirely on our technology and preparedness. We'd have to move underground to escape the deadly cold, relying on geothermal energy from the Earth's core. Or our remaining stockpiles of nuclear fuel to generate heat and electricity. We could potentially grow food using hydroponics under artificial lights powered by these sources. But it would be a grim, difficult existence, a life lived in a deep freeze without ever seeing the sun again. However, not all life would perish. Down in the deepest parts of the ocean, near hydrothermal vents, entire ecosystems exist that don't rely on sunlight at all. These are chemosynthetic organisms. They derive their energy from chemical reactions, feeding on minerals and heat spewing from the Earth's crust. For these creatures, life would go on completely undisturbed. They wouldn't even know the sun was gone. Life on Earth, in some form, would persist. Now, let's think bigger. What would our new solar system look like? It would be a ghost of its former self, a collection of dark, frozen worlds silently orbiting a single point of blackness. From a distance, another alien civilization might not even detect our solar system. They'd only notice it if they saw the stars behind our black hole being gravitationally lensed their light, would bent and distorted as it passed by, or perhaps they would detect the faint gravitational pull of our frozen planets. What about time itself? According to Einstein's theory of general relativity, massive objects warp the fabric of space-time, and this warping is what we experience as gravity. Black holes are extreme examples of this. They warp space-time so intensely that close to the event horizon, time slows down dramatically compared to time far away. This is called time dilation. So, if we sent a brave astronaut on a mission to fly close to our new solar mass black hole, time would pass much slower for them. They could orbit near the event horizon for what feels like a few hours to them, but when they returned to Earth, decades or even centuries might have passed. They would have effectively time-traveled into the future. Of course, this would be an incredibly dangerous mission. One wrong move, one slight miscalculation in thrust, and they would cross the event horizon, the point of no return, and be lost forever. Once inside the event horizon, the laws of physics as we know them break down. All paths lead to one place, the singularity at the center. The gravitational forces would be so extreme that they would stretch anything that falls in a process gruesomely nicknamed spaghettification. The part of your body closer to the singularity would be pulled so much more strongly than the part farther away that you would be stretched into a long, thin strand of atoms. A rather unpleasant end. Let's consider another aspect. What if the sun didn't just poof into a black hole, but went through the process that massive stars do a supernova? If our sun were massive enough to go supernova, the black hole would be the least of our worries. A supernova is a colossal explosion that, for a short time, can outshine an entire galaxy. If our sun did this, the sheer energy and radiation blast would instantly incinerate Earth. It would be vaporized, gone in a flash. There would be nothing left to orbit the resulting black hole. So, the instantaneous replacement scenario, as terrifying as it is actually the gentler option. So, to recap this cosmic nightmare, if the sun were replaced by a black hole of the same mass, Earth would not be sucked in. We would continue to orbit it, but we would be plunged into eternal darkness and a deep world-ending freeze. Surface life would be extinguished within months. Humanity's only hope would be to retreat deep underground, harnessing geothermal or nuclear power. It would be a dark, cold, and desperate existence. Lived on a rogue planet, wandering through the dark, it's a chilling thought experiment, isn't it? It really makes you appreciate that beautiful, life-giving star we see in the sky every day. The sun isn't just a light. It's the engine of our world, the provider of warmth, and the anchor of our very existence. Its stable, predictable nature is what allows life to flourish. Without it, we're just a cold rock adrift in the infinite void. So, the next time you feel the warmth of the sun on your skin, take a moment to be thankful. We live in an incredibly fortunate and delicate balance, orbiting a stable star in just the right spot, the Goldilocks zone. Let's appreciate the cosmic lottery we've won. What do you think is the most terrifying part of this scenario? The instant darkness, the bone-chilling cold, or the psychological horror of living on a planet without a sun? Let me know your thoughts down in the comments below. And if you enjoyed this journey into the abyss, please give this video a like. Subscribe to the channel for more mind-bending science. And don't forget to hit that notification bell so you're the first to know when we explore another cosmic question. Thanks for watching, and see you in the next one.